Looks like it's about 8:05, so I'll go ahead and start. I think we might have a couple of people joining us in just a few minutes. Again, good morning, everybody. Welcome to HomeSafe Colorado Safety Orientation. My name is Roman. A few of you I've met out in the field and in different events. I think the way we have this set up right now is everybody's muted to keep the interference to a minimum. If you guys have any questions, we're going to have a Q&A session at the end of this. But if it's something that you absolutely need to know, feel free to unmute yourself and ask. What is HomeSafe Colorado? The HomeSafe Colorado program is operated by the Jobsite Safety Committee of the HBA of Metro Denver, and the program objectives are basically reducing and eliminating job site hazards and helping to facilitate the goal of eliminating and or reducing occupational related fatalities and serious injuries in the residential construction industry. Besides obviously gaining some construction safety knowledge, the good thing about this orientation is it's also a stepping stone or a first step in a home builder becoming a master home builder. So receiving that HomeSafe Master Builder designation. So as you guys can see from the screen, this is step one, the orientation. Step two would be attending our Focus 4 field safety awareness class. And basically that's one of those things that we come out and actually teach on a job site. It's a little bit more expanded than this orientation. And then the third step and the final step in becoming a master builder would be, having your employees take the OSHA 10-hour class. We're going to talk a little bit more about that, but as the name suggests, it's basically a very expanded construction safety 10 contact hour course. Okay, these are typically have been taught in person over the course of 2 days, but with the conditions the way they are currently, a lot of people are also taking that online, which is kind of nice in the sense that you actually have more than just a couple of days. If you're busy with a project or whatever, you can always take it just in little increments, and you actually have 6 months to complete the course. So besides getting some safety knowledge, this is that first stepping stone in becoming a master builder. Safety, some of the things that kind of highlight the importance of safety and specifically occupational safety, and more specifically in construction. As you guys can see from the screen, the statistics that we have right now, basically about 5,000 workers die on the job in the United States every day. And I know that number doesn't seem very high with the conditions the way they are currently, but if you think about it, that's about 14 people a day. And obviously when something like that happens, it doesn't just affect the person that it happens to, but a lot of people, the family, friends, everybody that depends on that person for income and all those other things. And I think the stat below it is actually a little bit more telling, because the 5,000 is just fatalities. If you think about the actual injuries that occur in construction, the serious injuries that can keep somebody from working or whatever, those are actually a lot more common. So a worker is injured on the job in this country every 8.5 seconds, okay? Most accidents do occur within the employee's first 6 months on a new job. And so we attribute that to basically that person not being as aware of hazards as somebody who's a little bit more seasoned, and not having the training, not having the tools to basically get the job done safely. And then obviously the human element is the most important thing, but also the costs that go into an injury, not just a fatality, but an injury, are substantial. So you guys can see cost is basically $1 billion per week for US employers. And that includes things like lawsuits, but also things like having to hire new workers, having to train somebody to fill those skilled positions if an injury happens, and things like that. So just some of the things that basically highlight the importance of construction safety. A little bit about us, SFI Compliance. We've been in business. We actually had our 30-year anniversary last year. We've been in business for 30 years now. We're a safety consulting firm, and our mission is to provide companies and employees with up-to-date OSHA regulatory compliance training, hazardous communication awareness, first aid and safety training courses, and provide personal protective equipment and first aid to ensure personal safety at all times. Now, the bulk of our work is field work. We do a lot of inspections on different job sites, including many home builders in several different areas, but we also help by providing trainings like this one, more expanded trainings like the OSHA 10-hour that I mentioned, and we also do ride safety programs for our clients. This is basically going to be the layout of the course and things that we're hoping to achieve. We're going to discuss a little bit of a safety program and then basically hit on some of the very common safety issues and some of the standards that have ensued from OSHA because of those issues. And at the end of this, we're going to have a fun little quiz as well. Safety program policy: everyone performing business on a job site must have a safety program. The most successful accident prevention program includes a clear written statement of policy and has a complete support of the owner of the boss. Basically, safety is one of those things that comes from the top down. If management has support, typically a safety program will be effective. A safety program really has to be written because in safety, as in a lot of things, we have a saying that basically says if it's not written, it's not done. In order for communication to disseminate properly and to be effective, all working on a construction site, all employers working in construction have to have a written safety program. Some of the things that go into that: a safety program has to clearly state work procedures for safe and healthy working conditions. It must be available on the job site for everybody performing business. Safety program should be simple and easy to understand. So no matter who's reading it, they should be able to tell what that safety program is trying to convey. Safety programs are to be explained by management to all employees at the time of hiring or when needed. Programs should be available for review by all employees and subcontractors. This is one of those things why we push our home builders to always have a safety binder on site and to collect safety binders from the subs working on those sites. The last point there, the competent person, we're going to talk a little bit more detail about that, but basically competent person is an OSHA term, and it's basically a designation from any employer to one of their people, usually a site foreman, site supervisor, and per OSHA, a competent person has to meet two different definitions, okay? One is one who is capable of identifying existing or predictable hazard. So basically somebody who has safety training, okay? That's part number one. Part number two is somebody who has the authority to take prompt corrective measures, okay? So like I said, typically this is gonna be a foreman on a job site. But in case of an OSHA inspection, a lot of times this is, if you've ever been a part of one, you'll hear this term used a lot by the compliance officer: competent person, we need to talk to the competent person. So this is very important that the person that meets those definitions is actually designated by their employer for any project, okay? Again, they have to know what it is they're talking about. That's number one. Two, they have to be able to take corrective action. I always tell people the way you know is if something is wrong on a job site and you have to pick up a phone to call somebody about it, you're probably not that competent person, okay? A competent person is somebody that can stop that work the moment they see something unsafe. Getting into the OSHA standard, if any of you are familiar with the OSHA standard for construction, it's a nice big book written in a language that seemingly only lawyers can understand, about 600 pages worth. That book does not cover every single instance as far as safety goes that you may encounter on a construction site. And because of that, this is one of the main things that OSHA has in the very, very beginning of this book. And it's called the General Duty Clause, and it goes like this. Each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards that are causing or likely to cause death or serious physical harm to his employees. And basically what this is it's a catch-all. If something is not covered in the OSHA standard, but is a safety issue, OSHA can still cite that employer for it, and they would use this very general, very broad paragraph to do so, okay? So this is kind of the basis of the entire construction standard. And then the second part of it, an employer shall comply with occupational safety and health standards formulated under this act. So basically you have to follow what is in the OSHA book, okay? When it comes to OSHA, OSHA has basically two different things. They have employer responsibilities and employee responsibilities. These two things are basically the responsibility of the employer to provide that environment free of hazards and to make sure that they follow all the standards described in the OSHA book. On the flip side of that, the employer responsibility would basically be to make sure that they comply with all the standards as OSHA dictates, and also any rules or regulations that an employer may have that go above and beyond what OSHA requires. So employers have responsibilities, employees have responsibilities as well. A couple of things. One of the most important things in the safety program is what type of training our employees in the field receive. And there's various ways of providing that training. This would be one of those ways, through an orientation or something like that. But I would say the most popular and the most prevalent would be on-the-job training. So just with anybody else, when somebody's hired, they're typically going to be shadowing somebody, and that person who's kind of explaining the ropes to them is going to be, teaching them everything about the job. Same goes for safety. Okay. Safety meetings is another thing that employers can do. And this is one of those things that you typically don't need a lot of safety knowledge to be able to administer these. For a lot of clients that have our safety programs, we actually provide these topics to them, to where we keep these topics to a very minimal one-page, document, very simple, easy to read, as well as documentation for people that attended, so sign-in sheets, okay? And safety meetings, they typically don't need to be very long. They're typically about 15 to 20 minutes. If you go beyond that, you're at risk of losing the people that you're talking to, but it's important to make sure that these are held periodically. We recommend once a week on any GC or a home builder site, and it's 15 minutes, and preferably they're on topics that are relevant to that project. So project that may have a lot of framing, you would want to cover things like fall protection and things of that nature. Hazard communication, I think we need to update this slide because they changed the MSDS to just SDS now. But basically what hazard communication is, it's kind of your right to know requirement. And basically for anybody in construction that works with any type of chemical, be it, spray paint, cleaners, anything like that, those workers have a right to know the risks associated with working those chemicals and what to do in case they get some of that, on them or spill or anything like that. And for that reason, when we collect our safety binders from our subcontractors, we make sure that we review this section, because this could be different based on the project. Different project use different chemicals. But basically for any subcontractor that has a chemical on site, including the home builder, the GC, a lot of GCs tell us that we don't have any chemicals, we don't do any work. Well, typically in their office, every home builder is going to have some spray paint, some cleaners, maybe some glue, things like that. For every one of those, you're required to have an SDS, or a safety data sheet, which basically is a very short 3 to 4 page document that covers different things like, the hazards associated with handling the chemical, the precautions needed for transport, accidental release, and all those things. And then emergency action and fire prevention, very important that information is shared for anybody working on site as well. Other training options, like I said, the OSHA 10 and the 30-hour courses. The 10-hour course is 10 contact hours. Obviously, the 30-hour is more in depth. It's 30 hours of contact in person. That's a class that takes 4 days. Our recommendation is, for a lot of clients, I think at this point it might be wishful thinking, but that everybody on site has 10-hour training, anybody that works on site, and then site supervision has the 30-hour training. I think that's a very good guideline to have. And then HomeSafe Colorado, like I said, a course that we offer in the field on your all's job sites is another option for that. Jumping into some of the safety awareness issue, we'll go ahead and start with PPE, or personal protective equipment. And I do, before I get into specific PPE, just want to mention a couple of things about PPE. A lot of people in construction believe that all PPE, basic PPE, hard hats, safety glasses, and all that is an OSHA requirement on a construction site at all times. And that is not the case, okay? As far as OSHA, and keep in mind, OSHA standards and requirements are what we refer to as the bare minimum, If you guys have some that go above and beyond, that's great. But as far as PPE goes, any PPE, OSHA requires PPE to be used when there is a hazard. So per OSHA, hard hats on a construction site is required if there's an overhead hazard. So if there's overhead work going on, framing, roofing, things like that, or if there's any material stacked overhead, those would basically require hard hat use on site. Okay. Again, a lot of people brought up in construction used to working on multifamily and commercial sites where employers require that hard hats and safety glasses at all times. So that's kind of the reason for that misconception. But per OSHA, any PPE is hazard specific. Second thing about PPE, PPE should be considered the last line of defense, okay? Administrative controls and engineering controls always have to be put in place before we rely on PPE. And I'll just use hard hats as an example. A person working underneath some scaffold, with brick overhead and all that, hard hat does provide some protection. But a better way to protect that person would be coordinating that work to make sure that that person doesn't work underneath that scaffold when there's work going overhead. That would be an administrative control. Possibly using some kind of a canopy or some kind of a cover would be an engineering control. To the extent possible, we want to make sure those two things are in place. And then in addition, we would require PPE if the hazard still exists. Okay, so just want to kind of mention those things. Getting into hard hats, again, overhead hazard exists. You have to have a hard hat on a construction site. They can't just be any head protection. They can't be things like, bicycle helmets. You see a lot of things like climbing helmets and things like that on a construction site. They do have to actually meet ANSI standards. And what ANSI is, it's the American National Standards Institute. It's basically a sister agency to OSHA that does a lot of their testing. So they're the ones that actually take the hard hat and drop the brick on it from 20 feet to see if it holds up. And as such, anything that is ANSI approved or ANSI stamped is going to have that designation on it. So if you all have your hard hats, it should be real easy for you to find that ANSI Z89.1 somehow engraved on that hard hat. And that basically tells you that that is in fact an approved product. Another couple of things to keep in mind, as with any PPE has to be in good condition. So just want to make sure when we use our hard hats, we always check them for defects, making sure there's no cracks and shells, making sure that that suspension underneath the shell, the part that actually goes on our head, is in good condition, because that's really the most important part of a hard hat. Most manufacturers recommend that the actual shell, the hard shell of a hard hat, is switched up, changed every 5 years, and the actual suspension inside one is changed every year. Okay, and it's as far as seeing when a hard hat was manufactured, there's also those markings on those hard hats. So just a couple of things to be aware. Hard hats do have to be worn properly. So facing forward, ideally, we know people like to turn them around. The problem with that is if you turn a hard hat around and do nothing with the suspension part of it, the way it sits on your head, basically, if that brick is that you guys can see in the picture here, if that falls on your head, it's not going to absorb the contact properly. So making sure we wear our hard hats correctly is also big. Proper footwear. Again, a lot of people think that working in construction, you have to have safety toe footwear. Very, very much hazard specific. If your work includes handling heavy materials, bricks, CMU, framing, things like that, or using tools that could cause a potential injury like jackhammers, then yes, steel-toed and metatarsal protection would be required. Otherwise, footwear just has to be construction-grade footwear. Okay, so I think the big thing we run into on construction sites would be workers wearing things like tennis shoes and things like that. Proper clothing should be worn for the work being performed. That, again, depending on what you do at a construction site, this could be different things, but we always ask to make sure that shirts are worn with at least a 4-inch sleeve. Shorts, I know that's always a question that commonly comes up, specifically by superintendents running job sites. When it gets 90 to 95 degrees, it's really nice to wear shorts instead of long pants. Again, per OSHA, hazard specific. If you're somebody that just manages a construction site and don't actually do any labor yourself, there's nothing in the OSHA standard that says you can't wear shorts. But in these situations, we usually default to whatever that home builder's internal policy is. So if your policy is to wear shorts or wear long pants, then that has to be followed, obviously. Hand protection, again, very hazard specific. Typically in construction, for anything that you have to handle sharp materials for, like lath, things like that, would require you to have gloves. And then also anything that could cause a chemical burn. So I think the biggest thing on a construction site would be working with concrete. So those things would require hand protection. Eye protection, ear protection, hearing protection. So hearing is one of those things that...
Sorry about that, folks. If you can hear me, Roman will be rejoining our meeting shortly.
Hey, everybody, I apologize about that. Looks like I had a little bit of a connectivity issue. I think that's been resolved now.
Roman, we actually, it was kind of funny. You were on the slide that said hearing loss is, and you went completely silent. I thought you were actually, wow. You're actually making a point about how important it was.
So that was the intent. Just
yeah.
Again, I apologize, guys. Good to have anybody back. Hearing loss is permanent. So the biggest thing is making sure we treat it seriously for the workers that are exposed to it on a daily basis. Again, nothing missed on that slide, but basically the idea behind hearing protection is if you're standing 3 feet away from a person and you have to yell at them, that means it's too loud and you have to have something in place. So things as simple as earplugs, earmuffs go a long way. Safety glasses, very, very similar to hard hats. Not all glasses are safety glasses. Some sunglasses are just sunglasses. And the way to tell is basically to look for that marking, ANSI Z87.1. You see that anywhere on your sunglasses, your clear glasses, that basically means that those meet the standard. If you don't see that, that basically means that those are glasses that if there's any kind of impact, they're not going to hold up. Okay, so very important we make sure that we wear proper eyewear. Respirators is one of those things that's it's kind of a big topic of debate, and the big reason for it is people, if there's any kind of dust or nuisance, people automatically think putting on a respirator is gonna solve all their problems. And as far as the OSHA standard, that actually is a little bit more complicated than that. In order for anybody to wear a respirator, they actually have to have an evaluation by a medical professional saying that they're healthy and fit to wear one. Okay, that's one. And then two, you have to have it fit tested to you. Okay, so I think in instances like we deal a lot with silica now because of the OSHA standards have changed for silica. The big thing that we want to do is before we actually just start giving our employees respirators and having them go through the process of getting medically tested and all that, we want to make sure we exercise those engineering controls and administrative controls. So for example, with silica, which just a little bit of a background on silica, it's a very fine dust that's found basically in everything. When it becomes in dust forms, it's very small that it can enter your respiratory system and get all the way down in your lungs. And it's also very, very sharp. So it actually, scars your lungs, and it's a very dangerous thing. The big thing that we want to make sure that we do before we get into the respirators is we actually do some kind of a wet method or some kind of an exhaust method to our work. So things like having an exhaust system and a HEPA vacuum, or if we're maybe cutting concrete, things like that, continuous water supply, okay? You guys have probably seen these on road work. Guys that use big demo saws, they actually have a hose attached that's feeding water to that. And what that basically does is it keeps that dust from elevating into the operator's breathing zone, okay? And if your company determines that those things are not enough, then we would rely on respirator use and go through the process of getting evaluated and fit tested. Excavations and trenching. This is one of the more dangerous things in construction and often overlooked. Okay, A couple of things about soil. One, soil is very heavy, okay? A cubic foot of soil weighs about 120 pounds. In case of a cave-in, if a cave-in happens, it's very unlikely that just a cubic foot of soil is gonna cave in, okay? If it's a cubic yard, that's about 3,000 pounds. So imagine that on top of a person working in a trench, okay? That can obviously crush you, it can suffocate you, and all those other things. Now, we don't think a lot about this hazard because it's not like heights and falls where we can look down and be scared and protect ourselves. You know, a lot of these excavation trenching operations, they go overlooked as far as safety goes. But they are very, very dangerous because soil is, one, heavy, and two, as you guys will know from working in construction, you leave a trench open for long enough, it's gonna fill itself. That's just the way soil mechanics work. Because of the forces impacting the soil around that trench, sooner or later, you know, especially with weather conditions and all that, that soil is gonna cave in. And what happens a lot of times in construction is that cave-in occurs very, very suddenly. So if there's not a proper protection in that trench, the workers inside can get buried, okay? So very, very basic OSHA standard is anytime we have a trench over 5 feet or deeper, we have to have a protective system in place. You guys may notice that when a house excavation exceeds 7.5 feet, okay, so this is an exception for foundation work only, okay? We're given another 2.5 feet to work with. So basically, if your excavation in between your form wall and the actual excavation, if that height is over 7.5 feet tall, you have to have a protective system in place, which in foundation work is typically going to be benching or sloping. And what benching is, it's basically what you guys can see in the diagram. For every 5 feet that your excavation goes up, you have to cut it back 2 feet to make sort of a little pyramid shape, okay? And it only shows 2 benches in the drawing, but you can actually have a few more provided that you observe those distances. Every 5 feet up, you have to cut it 2 feet back. 5 feet up, 2 feet back. Now you can't do that forever. In home building, you're not gonna have to, but there is a 20-foot limit on that as well. Any excavation over 20 feet has to be designed by a registered engineer. But for our purposes, I think benching would be the most common way to provide cave-in protection. So just making sure this is a lot easier to do before we actually have the forms and the footings in place. Just look at your lots, make sure that if there's anywhere where we are over 7.5 feet deep, that we have our excavating contractor basically provide us with these steps or bench. So cave-in protection. The other thing is we want to make sure that workers are able to get in and out of these excavations safely. So the standard requires us on any excavation over 4 feet to have basically a ladder or a ramp for the people to get inside. And that has to be within 25 feet of any worker. If we can't do that, if the work is so spread out, then we're obviously going to have more than just one ladder. And you guys see that term at the bottom, again, the competent person. So this is one of the OSHA requirements, is that any excavation, any trench that's going to have people working in it, it has to be inspected by a competent person on a daily basis. And on a daily basis is because conditions change. If it rains overnight, the protective system, the benching that we had in place yesterday may not be as effective today. So that's the reason for that standard. A couple of things to consider: vehicles, any equipment that causes vibration, we want to make sure that that is kept a safe distance away from any trenches. And besides inspecting that excavation, the competent person has to remain on site anytime we have people working inside that excavation. And then as we're benching, as we're excavating, any spoils or any excess dirt that we pull out has to be placed at least 2 feet away from the edge of that excavation to prevent it from spilling inside and on top of the people working in it. Again, just to summarize a couple of things, trenches have to be examined by trained and competent person daily. Over 5 feet, a protective system is required. In home building, it's going to be either sloping or benching. There's some situations where that is not feasible, and there's other options available. You can use trench boxes, you can use shoring, things like that. We want to make sure we keep our access dirt at least 2 feet away from any excavation. Anything over 4 feet deep requires a ladder within 25 feet of any workers. And basically, if we're going to be going down more than 20 feet, that has to be designed specifically by a registered engineer for that particular instance. Last point on the erected barrier or warning system around the trench must be 5 feet from the edge. Basically, any trench or excavation that's going to be left, open for more than 24 hours and is not very visible, we want to make sure that we mark those with caution tape and things like that. Now, because it's not really a physical guardrail, it's more of a warning device, and it's not going to keep somebody from actually falling. We want to make sure it's not set at the very edge of the excavation. It's moved back just a little bit, so at least 5 feet. Getting into scaffolding, you guys see this a lot on your construction sites. Obviously, there's various kinds of scaffold, pump jacks, pretty common, mason scaffold. And so as far as scaffold goes, there's some general requirements that all scaffold has to follow, and then there's some that is very specific to things like pump jacks, baker scaffold, masonry scaffold. So we'll go ahead and cover some of the generals first. Safety scaffold has to be designed with a factor of 4-to-1 ratio by a qualified person. Basically, that means two things. One is job build scaffold is not allowed on construction sites. So all scaffold has to be engineered. All the components, frames, bracing, all those things have to be engineered, okay? And then the 4-to-1 basically means that whatever the manufacturer's weight limit on that scaffold, that has to, or whatever load you impose onto that scaffold, the manufacturer's limit on that scaffold has to be 4 times higher. Okay, so basically a safety factor of 4. Scaffold should only be erected, moved, and dismantled under the direct supervision of a competent person. So we see that term again, competent person, has to be there when it's erected, when it's dismantled, and anytime any work is being performed on the scaffold. Anybody working on the scaffold has to be trained in safety for that specific scaffold. And the biggest thing to me that says on construction sites is scaffold should not be shared, okay? A lot of times we have trades that come on site and they want to take advantage of the scaffold setup because it makes it easy for them instead of setting up their own ladders or whatever. We definitely discourage the practice because chances are that person that's borrowing the scaffold does not have the necessary training in the safety of that scaffold. Always use base plates and mud sills. Basically, that's something that basically makes our frames more stable, that makes sure that they don't sink in soil, okay? Work platforms have to be fully planked. So depending on the type of scaffold that you use, if it fits 5 planks, it has to have 5 planks on it. If it fits 3, it has to have 3, okay? All scaffolds shall be installed within 14 inches of a vertical wall, with the exception for stucco work, which is 18 inches. And basically the idea here is we want to make sure that we are protected in that area in between the building wall and where our scaffold ends. So that hole in between, if it's any more than 14 inches or 18 inches for stucco work, that is considered too much of a fall hazard and a person can fall through, okay? As far as the back side and the sides of the scaffold, any scaffold that is where we have people working 10 feet or above has to have fall protection. So it has to have guardrails installed, okay? Toe boards are required also at the same height, 10 feet or above. And what toe boards do is they're one of those engineering controls that we talked about. So they're what keeps the material from falling onto the people below. Safe means of access required for any scaffold over 2 feet, which really is any piece of scaffolding. Okay, so typically that is some type of a ladder, like a hook-on ladder or something like that. It could be a ladder that's specifically designed for that scaffold, or it can be a portable ladder provided that it's properly secured. And I think in the case of pump jacks, nothing is required because you can basically get onto the platform at ground and then raise your pump jacks that way. Scaffold must be properly braced and plumb or level. And then damaging scaffold components cannot be used. So if you guys run across damaged frames, bent, cracked, missing pins, those do have to come out of service. And we want to make sure we don't do any work on the scaffold in high winds. Some of the other, there are a lot of other rules for different types of scaffold. As you guys can see on the screen, the mason scaffold looks a lot different from pump jacks. The big things are fall protection, so our guardrails, access, and making sure we have a stable buildup. So you guys can see in both cases, one of the setups has base plates, the other setup has mud sills. Those things are pretty uniform. But then in case of pump jacks, there's some additional requirements, specifically the bracing, the way it's installed. We have to have bracing on top and the bottom. So you guys can see those triangular braces at the roof, but also at the bottom. So a lot of different types of scaffold with a lot of different specifics, but the big three things are fall protection at 10 feet, safe access anytime we're getting up more than 2 feet, and then some sort of a stable buildup. Ladders, big thing in home building, no job build ladders. You guys will see these occasionally on some multifamily projects where there's a need to have these. And to be honest with you, if there's no need to have these, building one and building one properly is a lot harder, and it's going to take a lot more time and money than just buying a portable ladder. So for that reason, in home building, we say no job build ladders. All ladders must be commercially rated, so no homeowner ladders. An easy way to tell, a real easy way to tell from far away, if an extension ladder, an aluminum extension ladder or an aluminum step ladder have red plastic tips on them, that's a dead giveaway. That is a homeowner ladder and it should not be used in construction, okay? Basically, they have a lesser weight capacity. All the other colors, yellow, blue, black, green, are perfectly fine. Just want to make sure we stay away from the red. A few more considerations. Want to make sure we set up our ladder on clean surfaces with no obstructions. When you climb the ladder, always want to face the ladder. You don't want to be walking on the ladder backwards. As you're climbing the ladder, you want to maintain 3 points of contact at all times. So we don't recommend carrying any materials and things like that you can't have, without having it in your hands. If you're working from a ladder, you can use both hands and not hold on to the ladder. This is strictly for access. But as you're climbing up and down, you want to make sure you have at least 2 hands and a foot touching the ladder, or 2 feet and a hand at all times. Want to try not to lean outside the ladder, so you want to keep your center of gravity between the side rails. Keep your boots clean of mud, grease, or any slippery materials that can cause loss of footing. Do not position ladders against flexible or movable surfaces, like the window in the picture. See that all too often, unfortunately. There is a proper way to set up an extension ladder, okay? And that is basically keeping a 4-to-1 ratio. So for every 4 feet that we go up, we want to be a foot away from the building. So if our ladder is 12 feet, it has to be at least 3 feet away from the building at the bottom. So we don't want it too steep, and we don't want it too flat, if that makes sense. Couple of quick things also on ladders. There's 2 different uses. One is for access, and the other is working from a ladder, okay? Working from a ladder, ladders obviously have to be in good positions, but they don't have to be tied off, okay? If you're using your ladder for access, meaning you're getting up to a platform somewhere and you actually have to get off the ladder, then that ladder has to be tied off or secured at the bottom and the top. And also, as you guys notice that in the drawing, they have that ladder extended 3 feet past where it is that they're going to be getting. And the reason we have that is in case you start to lose your balance as you're getting on and off the ladder. If you have that 3 feet of ladder in front of you, you have a chance to grab onto it and help yourself that way. So if you're using ladders for access, always secured and always 3 feet above the landing. Before erecting any ladders, you want to obviously make sure there's no electrical hazards. So you want to make sure there's no power lines, overhead power lines within 10 feet of that ladder. You want to make sure you don't use aluminum ladders near electricity, because they're very good conductors, and so are we as people. So if we're on that ladder, that's the danger. So 10 feet away from any live electricity. Ladders shall be maintained and repaired so they are in good condition. Anything that's defective, cracked side rails, missing rungs, any of those things, we need to make sure we take those ladders out of service. Electrical safety. I'm not going to give you guys a huge lesson in electricity, but the idea with electrical hazards is very, very simple. All electricity runs in a current. So it comes from somewhere, it goes, and then it comes back. And if something breaks that current, if that electricity can't come back to its source, basically that electricity, that current is looking for the fastest way to get into the ground. And if you happen to be in contact or have a part of your equipment that's in contact with that circuit, that fastest path to the ground could be through you. So that's really the hazard with electricity, okay? And there's a couple of things, a couple of safeguards that we have and use in construction. One of them is GFCI, so Ground Fault Circuit Interrupter System. And basically what that is, it's a device. It can be either portable or it can be installed in our outlets that if it senses the slightest difference between that electricity going out and the electricity coming back, it shuts off the power, okay? It works a lot like a breaker, except breakers are designed to protect more of the system, but the GFI is actually what protects our workers, okay? So you can, if you come into contact with that current, you could still get shocked, but that GFI comes on in like 1/40th of a second. So that shock is going to be very, very, very brief and therefore not as harmful. So all temporary 110 volt construction power must be on a GFI system. Using temporary power poles, that is usually, GFIs are already installed. So it's just a matter of testing them and make sure that they're working properly. The big thing with satisfying this requirement that we want to make sure that we do is when we're working in homes, kind of in the finished stages of production, and we're actually using the permanent power inside those homes, that we use GFI protected outlets. And typically in a home, those will be installed in our wet areas, so kitchens and bathrooms. An easy way to tell is if that outlet has the reset and the test button, that's GFI protected. So just making sure that if we're using permanent power, those are the outlets that we use inside homes, okay? And then I'm not going to read the rest of this because it kind of builds on the same thing. But then the other safeguard that we have in construction is, besides the GFCI, is going to be grounding. And what grounding is, it's basically it's another way that if that current from generating station back to the generating station gets broken, gets interrupted, there's an extra way that that electricity can get into the ground. Besides through the operator, and that's in our extension cords. When you guys see those three forks, that third round pin, that's the ground. Okay, so very important that our cords on construction sites are in good condition, so they don't have any kind of tears, things like that, but that they also have that ground pin in place. Now, unfortunately, if that ground pin gets broken off, the cord itself is still going to work. It's still going to function. But that added safeguard is no longer present. So please make sure you guys are checking your cords daily. Want to make sure they're good condition, making sure they're construction grade cords. And really the gauge of the cord will depend on the tool that you are going to be using with that cord. But we say that at least a 14 gauge should be used in construction, okay? No flat cords, no Romex cord. And we want to make sure that even if we're plugging into a GFI outlet, that we test those GFIs. Again, checking the cords, we're making sure there's no tears in the outer insulation. If you can see the inside cords, they're going to be the white, the black, and the green. If you can see those individual cables, that basically means that cord needs to either be repaired or possibly replaced, depending on the damage. With that in mind, we want to make sure we protect our cords. So not having them rub against anything that could be sharp, not having them run unprotected across roadways. Okay, I think that's a big issue that we see in construction when we're limited on our power supply. Not allowed to splice a cord unless it's 12 gauge or larger. And honestly, I would not recommend splicing a cord. If you have a break in the cord, you can cut it and make two cords out of it and put two outlets on it. I think that would be a little bit a better alternative than actually splicing an extension cord. Do not want to overload our circuits, because besides the shock hazard, anytime you plug too many cords into an outlet or whatever, have extension cords, 3-ways and things like that, there's also a chance of a fire starting, because those cords are working a lot harder, and so there's a potential for them to heat up and actually cause a fire. Access and housekeeping. Obviously, we want to make sure we have a safe site, a clean site. A lot of the accidents, especially falls that we have in constructions, unfortunately, they're very preventable. Little falls caused by little kind of dumb things like trash and things like that. Trip hazards. So we want to make sure our areas are always clean. We want to make sure anywhere you have to access on a construction site, you basically have at least 3 feet wide path to access those areas. Ramps, if you have a change of elevation more than 19 inches, by the way, this will be on the quiz at the end, you basically have to have a ramp or some kind of a step at it. Okay, the biggest thing that we see this issue with in home building would be our access from the garage. Okay, before the permanent ramps are installed, if that jump from the garage into the house is more than 19 inches, we have to have an additional ramp. Planking for ramps must be at least 20 inches wide. We want to make sure we have cleats to keep from slipping, and we should not have ramps longer than 8 feet. Getting a little bit more into fall protection, this section is actually divided into two sections. So it's going to be unprotected openings, and then the actual fall protection is going to do more with like the structural and using harnesses and things like that. But basically, again, the rule in construction is very simple. If you work over 6 feet in height, basically, if you can fall more than 6 feet, you have to have a conventional fall protection system in place, which is going to be either guardrails or a personal fall rest system. A lot of people think a lot of different things about the 6-foot requirement. Some people think it's overkill. Some people don't understand why it's 6 feet. The reason is very simple. It's very statistically driven. Okay, more than half fatalities that happen from falls in construction happen between 6 feet and 15 feet. Very, very surprising finding. A lot of people think it's falls from roofs and those high rises and things like that. I think when we are in those situations, that our natural fear kicks in a little bit better, and we protect ourselves better. But that area between 6 feet and 15 feet, a lot of times is overlooked because it doesn't really seem that dangerous. But stats speak for themselves. Okay, more than half of fatalities between 6 and 15. That's the reason for having the standard. So if you can fall 6 feet or more on your project, you have to have some sort of protection. And the OSHA requires, in a lot of instances, either using a harness or using guardrails. But I can tell you right now, a guardrail is always the preferred way to go. You're not always able to install it on every part of the project. Like, you can't install guardrails on the roof, obviously. You can, but we don't really see that in home building. But if you can, a guardrail is a better system because it's a preventative system. Once installed, there's not a whole lot that the workers in the area actually have to do. They're protected. Whereas with a personal fall rest system, there's a lot of things to consider, like free fall distances and always adjusting your slack and having an anchor point that's strong enough to support that fall. So my advice to anybody is, if you have a choice between guardrails and a personal fall rest, do the guardrails, okay? Very few guardrail requirements. Basically, they're going to be heights and capacity to support loads. Heights, you have to have two rails in place, one at 42 inches, one at 21 inches. And OSHA gives us a 3-inch either way leeway sort of a number. So basically 42 plus or minus 3. So anywhere from 39 to 45. That's a good guideline to use for your guys' windows on second floors and things like that. Typically our windows are, I think the sill of that window is 36 inches off the floor before the window's installed. So if that's the case, then an additional guardrail in that window is required because it is under 39 inches. And then the other part with guardrails is weight capacity. Any guardrail has to support at least 200 pounds of force. Okay. We don't expect anybody to actually physically test guardrails because that's how people go over. But if they are, you know, installed with the recommendations that we have in the next slide, those are deemed sufficient to support the 200 pounds. Any floor holes greater than 2 inches also have to be protected. Typically, if it's just over 2 inches, you're not going to build a guardrail around that. So it is acceptable to use covers. And usually it's things like floor vents, crawl space, openings, and things like that. Okay. So either guardrail, or if it's more practical, we can cover that hole. But basically a standard guardrail, like I said, 42 inches to 21 inches, and you have to have an upright support every 8 feet. So you guys can see in the picture, those uprights that they have are pretty close together. The idea is if you have at least them spaced, you know, at 8 feet up, or no more than 8 feet apart, those guardrails would be deemed sufficient to support the 200 pounds. So you don't have to test them, basically. Going down to the last paragraph, I think this is actually a misprint on our part, where studded walls are at 16 on center, around floor holes. So typically studded walls around like a stair hole, okay? What that should say is if it's 24 on center, then additional guardrails are required, because the standard says any opening over 18 inches has to be protected. So it's usually either 16 on center or 24 on center. If you have studs 16 on center, that is sufficient fall protection around those areas where you can fall more than 6 feet, like a stairwell. If it's 24 on center, then you actually have to have horizontal boards across those studs to protect. Window well covers are required because that is in fact an opening over 2 inches. And this is the diagram that you guys see below is basically our recommendation for what a window well cover should look like. So 2x4s, and then to satisfy that no hole greater than 2 inch requirements, we want to make sure that those boards are spaced no more than 1.5 inches apart. Fall protection. So this has to do a little bit more in those instances where having a guardrail is just not a possibility, like you guys see with a gentleman working on that roof. So if you can't have guardrails, but you're working in an area where you can fall, 6 feet or more, you have to use a personal fall arrest system, which basically consists of 3 things: wearing a full body harness, having some sort of a rope, lanyard, connector device, and then actually having an actual engineered anchor to where you can hook onto. Various systems out there, a lot of various systems for various activities. The big thing is we want to make sure we follow the manufacturer's recommendations. We want to make sure we select the right fall protection for our work. And then the big thing is there's some fall protection like retractable devices that basically the lifeline adjusts by itself based on your movement. But there's some where the operator has to constantly keep adjusting their lifeline to make sure that they don't have too much slack. Because a popular piece of equipment for our framers is a 50-foot vertical lifeline. Well, if you have a 50-foot vertical lifeline that is completely maxed out and you're working 20 feet above ground, you do the math. The worker is going to hit the ground. So we want to make sure that we use the system according to the manufacturer's recommendation and always maintaining it to make sure that it doesn't allow us to fall more than 6 feet. That's the OSHA requirement. Can't free fall more than 6 feet. However, the best thing to do is to use your fall protection and adjust it in such a way where you can't fall at all. So this guy had his lifeline more of a kind of a short leash type of scenario where it wouldn't allow him to fall off that roof. That would be the best and the most recommended way to go. Because there's a lot of things to consider. If you fall and your system catches you, how do you get down? How long can you be just hanging there like this guy is with all those forces of your body and the harness and cutting off your circulation and things like that? So it's obviously better not to fall, period. That's why guardrails are preferred. But if you are using a personal fall arrest system, Just make sure you always adjust your lifelines to keep you from actually going over the edge. And again, I believe this is mentioned either here or next slide, but this is another one of those instances where if work is taking place where somebody's exposed to 6 feet or more, a competent person has to be on site all the time. So really 3 instances in construction, 3 big instances: excavations, any work on scaffold, and any fall protection. You're going to see in the requirements, competent person on site all the time. Power tools and motorized equipment. Really, the idea here is very simple. You want to make sure you use the tool the way it is intended by the manufacturer to be used. That's number 1. Number 2, if your tool comes with a safeguard, whatever that is, if it's a saw, it will have some kind of a guard. If it's like a nail gun, it's going to have some sort of a safety spring. If a guard comes with that tool, it has to be on that tool while you're operating it. Okay. Powder actuated tools specifically require operators to be certified. So we see our, I think, framers and sometimes our concrete crews and sometimes our lathing crews use these. So that's a certification that's pretty easy to get. It's usually by reaching out to the manufacturer of that tool, and they can come out and train the operators and provide that, to them. Forklifts, a very, very popular equipment to use in construction. This is I think the only piece of motorized equipment on construction that specifically requires a certification. Everything else requires training, and it's a good idea to have proof of that training, but the forklift specifically requires all operators to be certified. Certifications are good for 3 years. So when you guys are talking with your operators, make sure you're looking for that. Obviously, they have to be in good operating condition. You have to wear a seatbelt all the time inside a forklift. If it comes with a seatbelt, you have to wear it. That's not so much for like it is in our cars for getting into an accident and something like that. It's more for rollovers. If you roll over, forklifts are equipped with overhead protection, those cages that they have. Well, it does us no good if the operator falls out of the vehicle. So for that reason, if you see anybody in a forklift, doesn't matter how fast they're going, even if they're just sitting there operating the forklift, seatbelts required at all times. Want to use our forklifts the way they're intended to be used. That is to raise and to lower materials, never people, unless they're in an approved attachment, and still not recommended. If you have your forklift and you need to have the forks up because you're loading materials or whatever, the operator of that forklift has to stay inside the machine. This is a difficult one in home building because a lot of times the guy that's unloading from the forks is the same guy that's operating the machine. But if you have a load up, you have to have somebody in that machine. Do not allow anybody to pass underneath the forks, underneath any part of the boom when it's elevated. And we want to make sure when we're driving our forklifts, we keep our forks as low to the ground as possible. Personnel platforms, this basically goes into using attachments to lift people in the forklift. And the big thing on there is the bullet point number 1. Manufacturer of the forklift must approve the use of a personal platform for that forklift. Unless it's the same manufacturer for both the platform and the machine, they're not going to approve it. So just be very mindful of that. Can't have job build platforms. They do have to be engineered. So with a solid floor. Does have to have a guardrail, and whoever's working inside that platform also has to use a personal fall rest. In this case, it's not an either or. It is having both. Platforms have to be secured to the forks. Cannot move platforms horizontally while the platform is occupied. Basically, what that means is you can only raise your boom up and down when you have somebody in the basket. You can't drive the machine with somebody in the basket. If you need to reposition the machine, you need to put that basket down, and the person in the basket has to exit. And of course, again, if you have somebody inside the box on the machine, just with elevated forks, you have to have an operator inside that machine. So that covers, I think some of the most prevalent hazards and some of the most prevalent standards that OSHA has in place. I will go ahead and start with this quiz. And if you guys are able to unmute yourself, and if you guys are wanting to feed us answers to this, we'll go ahead and get started. Question number one, a worker is injured every how many seconds in this country? Eight seconds, so substantial. Every 8 seconds, somebody in this country gets hurt on the job, okay? Each what shall comply with occupational safety and health and rules and regulations and orders issued pursuant to this act, which are applicable to his or her actions and conduct. Each employee, so we talked about employer responsibilities and employer responsibilities. Employers are responsible for furnishing a safe environment. Employees are responsible for following the rules that come working in that environment. Construction employees on the job site must use proper what when hazards exist or there's a potential for injury?
PPE.
PPE, correct, personal protective equipment. Again, very, very hazard specific. A trained what must be present at all times while employees are working in trenches or excavations?
Competent.
Competent person is correct. The other situations where that is the case would be scaffolding and fall protection. Scaffolding component, which scaffolding components shall be removed from the job site? Anything defective, anything damaged. So that could be a number of things. Like I said, bent frames, missing pins, any of those things. Always do what with a ladder when climbing up or down?
Have 3 points of contact.
Have 3 points of contact is correct. I think the one that they're asking for here specifically will be facing the ladder, which is pretty common sense, but you guys see it. There'll be a guy running backwards on the ladder every now and then. Electrical extension cords must be a minimum what gauge in construction? $14 gauge. We ask for at least a 14 gauge. Again, varies based on the equipment that you're using it. More heavy duty equipment is going to require a lower gauge. Ramps and or temporary stairs must be placed at points of access into a house where the stepping distance is greater than 19 inches. Anytime we have to jump more than 19 inches, we have to have another step or a ramp, preferably a ramp and not like a bucket or something like that. A standard guardrail constructed of 2x4 equivalent material and consists of a top rail set at and a mid rail set at, so they're asking for heights and how many feet between vertical uprights. So remember, 42 inches is the top rail, 21 inches for the mid rail, plus or minus 3 inches. So 45 to 39, 18 to 24, a vertical upright every 4 feet, every 8 feet. Fall protection is required when a worker is exposed to a fall of what distance? 6 feet. 6 feet for pretty much anything in construction, except one exception would be scaffolding, and that is at 10 feet. That is our orientation for today. If you guys have any questions or any clarification on anything we discussed today, please let me know.
Thank you.
Thank you.
Thanks, Roman.
Thank you.